Okay, good morning, guys. Let us start with the land acknowledgement. We are hosted on the lands in Mississauga of Naushabie and the Haudenosaunee Confederacy and the Wendat. We also recognize and during the presence of all First Nations, Métis, and Inuit people. Okay, today's Thursday, August 17th. Today's day 13. So today we're going to cover, this is the last section. Actually, this is people are coming in. So to define how this goes, this is the last day of not the last, well, it's not the last day of school, but this is the last topic that I'm going to teach you. That's it. This is the last topic. Okay. There's no Unit 5 test. So you understand there's no Unit 5 test, but there is going to be a quiz for this, just like how there was a quiz for on yesterday, there was a quiz for this, right? So there's no Unit 5 test. And basically tomorrow, which is Friday, I'm going to give you the written portion of the collimating part A. And then next week, and this will be due on Monday. Okay. By the way, if someone's going to ask me a question, is there an exam? There's no exam. Okay. So there's no exams. So you're basically, after today, there's no new material. I'm just going to repeat this again because people are coming in late. After today, so wait, people join. After today, there's no new material. That is it. Today is the last stuff. Simple interest, compound interest, present value, annuity. This is the last thing that you'll learn for the course. Okay. There is a quiz for this, and then you're done Unit 5. Okay. There's no unit test for 5. There's just two big quizzes. That's it. Tomorrow, you're going to get the collimating part A, which is a bunch of written questions. Okay. And it'll be due on Monday. So that means you have the whole weekend to work on it. Okay. You literally have the whole weekend to work on it. It'll be due on Monday at like midnight. Okay. There's no credit recovery days. Okay. This is not like day school. There's no credit recovery days. Okay. Again, the collimating, so you understand the collimating, there's two collimatings. It's worth 30%. If you want to talk about credit recovery, do well on the collimating because they're worth 30% of the entire mark. Okay. So credit recovery on tests, no, it is this here is a lot more than any other test you put together. And then there's a part A and there's a part B. Okay. So you got to work well on part A, part B. That's worth 30% of all your marks. So, okay, so focus on that. Don't focus on a past test to redo. That it counts for nothing in a grand scheme of things. If this is worth 30%, and then the part B is worth combined together is worth 30%. Okay, so let us start content. I'm viewing as a student, so hopefully we get to see everything that you guys can see. So we're going to go into simple interest. Okay, so let's just play this one.
Other portion here. We've now come to the final part of our course, which is going to deal with financial applications. In this part of the course, we're going to discuss such topics as interest, and we're going to talk about the different types of interest that exist. And we'll also talk about something called annuities. Both interest and annuities occur very often in our lives, especially as you get older and older and you invest money or you purchase things that are really expensive. So we're going to go over what the different types of interest are, what annuities are, and how they can relate to what will happen in your life. So before we get to there, though, we need to discuss, first of all, what is interest? You've heard the word before, and you've probably think of interest as all that extra money you earn by putting your money into a savings account, and it just sits there, and then the bank just gives you money, and that's interest. Well, what is interest? Interest, by definition, is essentially a fee that is paid to someone for letting them borrow your money. So when you put your money into a bank account, you're essentially giving your money to the bank so that the bank can use it for other things. It could spend it on uh, other financial things, or it could lend it out to other people, or whatever. But essentially, the bank is using your money for their own good. So they're going to be paying you interest as their fee for being able to use your money. Just like if you borrow money from the bank, whether you're buying a car.
Okay, so we kind of understand what interest is, right? So let's just fast forward. Okay, we have to get into the calculations because we have a lot of things to cover. Okay, so that's what interest is basically the money is a fee for someone using your money. Either when you say for someone using your money, that means the bank is using your money, so they give you interest, or interest is the fee, again, fee for using money, maybe the fee for you using the money when you put something on a credit card because you don't have any money, right? So you buy something on your credit card, or you take a loan to buy a car, or you take a loan to buy a house, that's like mortgage. Again, you get paid, you are charged interest, okay? So let's go into, and right now we're just going to talk about simple interest. There are two types of interest. Okay, people are coming in. So there's two types of interest, right? One is simple interest. Okay, just fast forward. I went too quick. So we have simple interest and compound interest. Simple interest is not as realistic, but for calculation purpose, we're gonna have to go through simple interest. Compound interest is in everything, right? And you'll understand why compound interest, you actually are charged more on compound interest. Okay, so let's get into it right now.
All right, let's get to what simple interest is. Simple interest is actually very easy to calculate. Perhaps that's where they came up with the name. It's calculated by multiplying the principal by the annual rate of interest. And then depending on how much that amount of money is in the investment, we're going to then multiply that by time. Things to note here, time we always reference in years. So if the time...
Okay, so let's look at a couple of things here, right? So I know he's gonna do it on the screen, but I'm gonna write it over here. Interest, there's a calculation for that. Okay, it's gonna equal to your principal times your interest rate and times your time. Times in years, interest rate is in decimals, and principal is the amount of money at the very beginning. Okay. And then later on, you want to calculate how much money, how much you had to pay back. Well, how much you had to pay back is your interest plus your principal. Principal is the initial amount, okay? The money there that was at the very beginning, okay, or the money that you borrowed at the very beginning, or the money that you gave to the bank, right? And then they pay you back, interest. And then your final amount, A is your final amount, your future amount, plus equals to your interest plus your current amount, okay? So that is the calculation for a simple interest. He's going to talk about it, but let's see. Let's get into calculations just to speed it up. There you go. That's the formula I just showed you. Interest equal to principal times interest rate, which is in decimal, okay? And time, which is in years. Now time is in years. So if I have, so let's look at this now. If time's in years, and if I say your interest is based on 30 days, okay? So now, because time's in years, I have to convert 30 days in terms of years. Well, you know that there's 365 days in the year, so time would actually be 30 over 365. That would be the fraction, okay? Because you have to put this in years, so that becomes years. If I said, 11 months, that means I would have to put time in terms of 11 over 12 because it's 12 months in a year, okay? So that's what I mean. It has to be in terms of years. That's when you're dealing with simple interest, okay? So let's clear that. So let's get into, and here is the amount that you have to pay back, or the amount that you used for that you have to pay back the lender. It would be the principal plus your interest. So let's go into calculations. Okay, so here's a calculation. So let's do this one.
5% per year, simple interest for 3 years. Okay, well, how much interest? So we want to know what the amount of interest is. Remember,
Okay, so we're gonna go a little bit quicker because we still have to cover other things. So we know we're gonna calculate what the interest is. 5%, you have to turn that to decimal, so 0.005, 0.05. Well, that's the formula, right? I is equal to P times R times T, and we said the principal is 1,200, the initial amount. Your interest is 5%, so you have to put that in decimal. There you go, 0.05, and your time is in years, so they say it's 3 years. Okay, so that's it. So that's going to be your interest. Punch that in your calculator, and you get 180. Okay, right? So now there's some special terms here. When it says 8% per annum, that's another word to say per year. Okay, so you may have different words. It may say per year, per annum, or annually. All mean the same thing. It just means per year. Okay, it all means the same thing. Okay, it means per year. So if I have 8% per annum simple interest now, and for 7 months, okay, so my month is 7, it's not even a year, so I have to make everything in terms of years. So it says here, remember that time is always measured in years, right? So if the question has a period in months, days, okay, you have to represent it as a fraction of a year. So I have to represent 7 months as a fraction of a year. Okay, so now let's go ahead. Let's do the formula. I equals to PRT. Okay, let's fast forward. He's putting time in terms of years, so it'd be 7 over 12. So my formula is going to be 1,200 times 0.08 for 8%, and then 7 over 12. And then I get my calculation, 56. Okay. Now the next one is simple interest in terms of 90 days. Well, I have to put 90 days in terms of years, so it'll be 90 over 365. So we'll fast forward that one. We know it's 1,200 times the interest rate of 0.0425 and times 90 over 365, because 90 has to be in terms of years. So 90 over 365 days gives you that in years. There you go. That's what you put in there, and then you get your calculation for what is the interest. okay? And the interest is $12.5 or $12.58. What amount must be paid back at the end of the lending period? So for each of these, the lending period to say is 3 years or 7 months or 90 days. So all you have to do is add 1,200 plus the interest, okay? So in each case, the interest is different, so it'll be 1,200 plus each of the different interests will give you how much you get paid, how much you have to pay back. So there you go. Amount is equal to principal, which is 1,200 plus the interest. So A is going to equal to 1,386. B would be 1,256 because the interest was 56, and then C would be $1,212.58. Okay.
58 cents. Here's one final example to look at. Gertrude deposits $500 into a guaranteed investment certificate, or otherwise known as a GIC. You may have put money, or maybe your parents or your grandparents have put money for you into something that's called a GIC. Essentially, it's an account that you can put money in that earns interest over time. That's different than a savings account. So you can't take that money out until that time is expired. So you'll see this come up a lot. So $500 got put into a GIC and it earns 6% per year simple interest. Part A asks us to develop a linear model to relate the amount that's in the account to time. So here's what we can do. If we're relating it to a linear model, remember linear models we can always write as y equals mx plus b. That's the equation of a line. So our two variables are y and x. But because we're going to be relating the amount in our account to time, we're going to replace y and x with amount and time. And the two variables that make sense for this would be to replace the y with the amount and the x with time.
Okay. So one of the things we have to understand is that we're talking about writing this in the money and the interest that's earned, and writing it in part B, developing a linear model. Okay. So when we say linear, right, we're talking about a line, right? Right. That's what we're talking about, a line, not a parabola, not an exponential, not a, a sinusoidal curve. No, we're talking about a straight line because that's how it's going to grow. It's going to grow in a straight line. So now let me erase this. So if I'm drawing this as a straight line, on this side here is money, right? And on this side down here, my x is time. Okay. My time is independent. That's why it's down here. And my money is dependent. It's dependent on time, right? Somebody just came into I gotta sign someone in. Where are they? Okay. So if I'm saying I'm going to write this deposit and the certificate and the interest earned as a linear, I'm going to start, my starting point is going to be 500, right? So I'm starting at 500. So let me draw my graph. I'm starting at 500 and I'm going to grow every year by 6%. So I start off at 500 and every year I'm growing by 6%. Year 1, year 2, year 3, year 4, year 5, right? I'm growing by 6%. So if we're looking at this, and now we're going to go back, and so here is basically my amount. This is actually amount A, and down here is actually my time, right? So we're going to put here T. Okay. and how much it grows, right, is my rise over run, right? Rise over run. But actually how much it grows is actually the same as my interest, right? It's going to grow by my interest. So when you look at over here, right? Over here, we're saying A represents Y, which is what we have over here. And M represents the interest because it's growing by that interest, right? So this would be R. And my Y-intercept is the starting point. So my starting point is 500. So that would be my linear formula, right? A is equal to, and when you think about this, right? This, now let me just look at this again. Let me clarify this. This is not just R, because R, we gotta multiply by the actual interest. So it's actually, sorry, by the principal, right? So you're multiplying by the principal. A is equal to, so this is going to be P, right? In order to get whatever the amount is, right? Whatever this grows by, so whatever that grows by, it's actually, you have to get the amount. The amount is actually, in dollars, it's actually P times R, right? That will give you the amount in dollars it grew each year, right? Otherwise, if I just say R, that's a decimal. I need to know the amount in dollars it grew each year. That's year 1, year 2, right? How much to grow by? Right now it's at 500, maybe it's gonna be 505, I don't know, maybe 510. So this here is actually PRT. So now you can see how that represents this, right? Right? This represents your interest. And you can see here, this represents your principal amount, which is your starting point, right? Okay, so you can see where now I have here my formula. Y is equal to A, which is my initial amount. M is equal to my interest. My interest is the dollar amount, which is equal to PRT or PR. And then we can, well, PRT altogether gives you the interest. And then my, then adding it to my principal amount, okay? So that's what you have there. And then, you know, so that would be question A. And then it says here, how long would it take for the nearest month for the investment to double? Well, how long would it take it to go to 500 to 1,000? If you're going to follow this, your graph, how you look at your graph and how long it take you to get to 1,000 if I started off at 500, okay? So that is sort of your model there. And so I'm going to clear this so we can follow the rest of the video. So there you go. Let's fast forward a little bit. There you go. It's 500. And there you go. That's your, like I said, that was your interest right there, right? Which represents M, which is your slope. And then it goes up times by T, and T represents your X axis. Okay, so there you go. So that would be your formula right there. This would represent this, right? Because now we know it's going to go $30 per year, right? because it's 500 times 6%. So it's gonna go up $30 per year. Now B is how long it takes to get to for it to double. So if that's the question, and if you come up with the formula, right? How long it takes to double. So now if my formula I already created is equal to A, my linear formula is equal to 30t plus 500. Now my future, now I want to calculate time, but my future amount has to be 1,000, right? So I'm going to calculate, I'm going to put here 1,000, and then I'll have to solve for t. If I solve for t, then I'll know how long it took to get to from 500 to 1,000, right? Isolate, solve for t. Okay, so that's how you would do that. I won't go through the process of solving. We need to pick up the pace. I'll fast forward the video. There you go. And then you solve for t. And t will let you know how long it takes for it to get to 1,000. Takes you, and this is in years, it'll take you 16 years based on that, from go to 500 to 1,000. Well, this is 16.6. So if you change that decimal into years, you'll get 0.8 months. Okay, so now the question, what's the annual interest rate must be earned so that the investment doubles in 8 years? So now I want my investment to double in 8 years. What is the interest rate? So I already know my years is 8, and I know for it to double, that means I know my A is 1,000, but I have to figure out what is my R, which is my interest rate. So here we go. We can rewrite it again. 1,000, which we know is the future, right? And we're gonna go by based on that. And we know that our principal is 500 times R and then times 8. We don't know what R is. We want to know what R is in order for it to double, because we don't want to wait 16 years. Maybe 16 years is too long. We want it to double in 8 years. So what would the interest rate has to be in order for it to double in 8 years versus 16 years? And that's what you're calculating here, right? And you look at that, you solve for R. Once you solve for R, then you're going to see the interest rate has to be 12%, right? 12.5%, right? 12.5% is what it'd have to be for it to double, okay? So now we're gonna go into simple interest. That was simple interest. Now we're gonna go into compound interest, okay? And then we're gonna go into present value and then annuities. So let's go into compound interest.
And we've been looking at tax, discount, markup, and simple interest, and now it's time for compound interest. Let's take a look at that. All right, here's the formula for compound interest. It looks pretty complicated, but I'm going to break it down for you. A is the total amount that you will have in your account.
So just like before, A is total amount, okay? Is the future amount, if you want to call it, okay? P is your principal, like we talked about from before. R is your interest in decimal. Something new that you guys haven't seen is compounding period. N is your compounding period. We have to talk about that a little bit more, but we'll look at it further. So let me fast forward it. So total amount is your A, which is what we've learned from before, is the future amount. P is your principal. In this case, it's we invest 5,000, so that P would be your principal would be 5,000. Interest rate 5%, which is R. And then we talk about N is compounding period. Okay. Now with compounding period, compounding means when is the interest rate applied? So we have to talk about this a little bit, right? I know he's going to talk about it, but let me give you a preview of it. N is compounding period, right? So if you have, if it's compounded annually, like in this case, let me just do different variations because there's different variations now. So if it's saying compounded annually, that means how many times my interest is applied to my principal, my N is going to equal to 1. When it says monthly, when it's compounded monthly, I'm not even writing properly, guys. Sorry. When it's compounded monthly, that means your N is monthly. The compounding periods, that means interest is going to be applied every month, so it's 12. If it's compounded daily, that means interest is applied daily. And what is N? N is going to be, well, daily means, and this is all in 1 year. That means N is going to be 365. Okay. You know, and then there's quarterly, and then there's semi-annually. So semi-annually means twice a year. Quarterly means every 4 months. So that will determine what this would be, and then what this would be, depending on what your N is, and depending on the question. Okay. So let's continue.
The simplest case. Now, if it says compounded monthly, that would be 12 because it would be compounded 12 times in a year. Compounding just means calculated, and whatever the new amount is, it gets added in to the principal. Okay, so compounded annually would be a 1 value there. Now this N times T, again, N is the number of times compounded per year, and T is the time period in years. Okay, always in years. Now I want to talk about this exponent right here. All right, here's a shortcut. Instead of figuring out the N and the T and multiplying it, what it really means is how many times compounded during the time period. Again, it's how many times compounded during the time period given.
Okay, so during the time period. Okay, so basically during the time period given, here we're saying it's going to be invested for 3 years. Okay. Now, everything's in terms of years. You may have it like, say, 12, we call it maybe 11 months. Then T is going to be 11 over 12. Okay. But your N will depend on if it's compounded annually or monthly or daily or quarterly. Okay. So in this case here, my T is going to be 3 and my N is 1. So this exponent is going to be 3 because it's going to be 1 times 3. Okay. So let me play it out.
So this exponent here, this N times T part, just think of it as how many times is it compounded in 3 years? Once a year. Well, obviously that will be 3. Okay, that's kind of a shortcut. Another thing about this formula is this 1 plus. This is the interest rate broken down into how many times it's compounded. Every time it's compounded, it's broken up per year. So this whole thing is 100% plus the additional percent. Okay, and because you're adding it, that's what increases the amount. So you start with principal, and then these two parts here actually calculate the interest and add it on.
Okay, so let's fast forward into an example. Here's an example here. Shirley learns that her savings account is compounded monthly, and she has $12,300 in the account, and how much you'll have in 2.5 years at 3% interest. So let's write out things that we know, okay? We know our P is 12,300. Come on, my pen's not working. Okay, we know that's that. We know the R is 3%, so we write it as a decimal, 0.03. What else? We know our time is 2.5 years, right? So 2.5 years, it just means 2.5, okay? And our N is the compounding period. And our N is what? Saying here, compounded monthly, that means our N is going to be 12, okay? So we have everything. That means it's going to be R divided by N, and then N is going to be N times N. So we have all this, and we can calculate our future amount, okay? So,
monthly. If she has 12,000.
so let's fast forward. You'll write down the numbers that we have on the side there. Okay. Let me move this out of the way so we can actually see. Okay, so 1 plus, right? 0.03 divided by 12, because our 12 is the number of compounding periods. Okay, and our exponent is going to be 2.5 times N, and N is 12. Right? So 2.5 times 12 gives you 30. Okay, let me back up. I want him to actually hear him. I want you guys to hear him say that. Right? So I don't think he just did 2 point. You just see 30 there. How did 30 come up? Well, 2.5. Well, just think about it. 2.5. Let me actually just write it on the screen. That way, when you guys go back and look, you'll see. This is equal to 12 times 2.5. Right? So 2 times 12 is 24, times 0.5 is 30. So that's how we got 30. Okay? Okay, so you got 30, and our final answer on the calculator, that's what goes on in there. And for our interest, our final answer is going to be, okay, well, that's to the exponent. So you can see there's a lot of things going on there, right? And our final answer is going to be, so in 2.5 years, it went from $12,300 to $13,256, right? That's what happened in 2.5 years. Okay.
$1,300 with almost another $1,000 earned at the end of 2.5 years. All right, so it's all built in. It's a
Okay, so now we got just different examples, right? So I'm just gonna write the formula here, and the calculations you can figure out later on. Okay, so for each of these, I'll just write down. So this one here, so our formula is always A is equal to P bracket 1 plus R over N, and it would be N times T. That's always our formula, right? So for each of these, we're just going to plug in, what's the principal, what's the interest, what's the compounding period, and then you'll figure out what the time, the exponent is. Okay. So for this one, we'll write the answer. P is equal to 54,402, 4,200, 1 plus, and then R is 0.056 divided by the compounding period. It says semi-annually. So semi-annually means N is 2. Okay, so my compounding period is 2. And then it says how many for the exponent, it's going to be 2 times how many years? Well, it's 2 years. Okay, and so on. So you get the idea, right? This is annually, so you guys can do that one. This is quarterly, so I'll do this one. This is a little bit tricky, but it's quarterly. So quarterly means my N is 4. So if I write this one, A would equal to our P, which is 1,900. And it'll be 1 plus R over, and R is 0.066 divided by the compounding periods, and it's quarterly, so it'll be 4. And then our exponent would be 4 times T. So 4 times T, and T is 2 years. Okay, so that's how you do that question, these questions, okay? And then you get the final answer. So let me fast forward. I'm gonna have to.
24, and good luck. All right, number 21. You can see.
Okay, so I'm gonna fast forward because we did all these already. And basically he's going through all of them, okay? And that is our simple interest, sorry, our compound interest, okay? So now let's go into, well, hopefully we got some time. We're gonna go into annuities. So present value, we're gonna calculate. Present value is, okay, well, let's go through present value. Annuities is longer, but we'll go through present value quicker. Let's see if I use this video or this video, which one's a better video? Oh, no, that's present value annuities. This is present value, so let's just do this one. So present value is like opposite to the future value, right? So let's fast forward. I'll give you an example. So with present value, we're going to still use the same formula, right? Right? The only difference is, what we're trying to do is, if it, say for example, I want to save, I want to have, you know, maybe $1,000 in the future. Okay, that's our A. I want to have $1,000 in the future. What do I have to put money down in? And maybe my interest rate now is, I don't know, could be 12%, and it's compounded yearly, right? So 1 plus point, and it's compound yearly, and I want $1,000 in, say, 3 years, right? So I have to basically calculate what is my P. What is my present value right now? That's what, because P we talked about, it was principal. Now we're going to say, instead of the word principal, we're going to say present value. What is it? What I need now in order for the future, which is A, to get $1,000, and my interest rate is going to be 12%. So we're doing opposite of calculating the future amount. We want to calculate the present amount. So that's what we're doing here. So I want to go through this quickly because I want to get to annuities. So let me clear this. So let's see if I can go through.
End up with some end amount. These questions will.
So let's look at here. A is our future amount, we said, and P is our present amount. That's what we just said, right? So we write the formula like that, but now we want to rewrite it. So we want to calculate, have P by itself. We isolate P. That's just showing you how to isolate P. Okay. And we also change wording. We also change the variable. So present value is also PV, and future amount is A. So let's look at this again. We're going to rewrite the formula down here. There you go. So present value, which is our P, is equal to our future amount, which is A, plus whatever interest in the formula that we need here. Okay, so you can see here, it's going to be minus N. Okay, or basically our exponent is just a minus. It's not just N, but our whole exponent is a minus. Okay, here's an example. I won't go through too quickly. I'll just go through one example. See, finding the present value. Kyle, who's in grade 9, wants to invest who's in grade 9 wants to invest money so that he can buy a $1,000 computer for university 4 years from now. So 4 years from now, he wants to buy a $1,000 computer. So he's going to invest his money at 6.5% compounded semi-annually. How much will he need to invest now in order to get $1,000 in the future? Okay, so here's our formula: present value equals to our future value. Okay, and that is it there. So now, how we got 8? Well, it's N. It shouldn't be just N. It should be N times T. That's sort of the thing that's messing everybody up. Right over here. It should be N times T. Okay, so that means N times T is equal to, it's compounded semi-annually, so it's 2, and we have 4 years. So that's how they got 8. Okay, so it's minus 8 because that's how they got 8. Okay, so let's fast forward. Right, and that's basically your answer. He has to have $774 now in order to have, in 4 years, $1,000 in that account. Okay, so that's what we're doing. So let me go into annuities. You may have to do the rest on your own because we're going to have to stop at 10. We got 6 minutes to go, so hopefully let's cover annuities. Let's go through here.
Over the last few lessons, we have discussed ways in which people have invested money into accounts that are earning interest, both simple interest and compound interest. For all of these examples, though, all we've done is we've put in one principal payment and let it run for a period of time, and then calculated the amount that was left at the end of the period. Interest was accumulated throughout, but in the real world, this isn't really how things work. People don't just put one payment into an account. A lot of times investors will make what we call regular payments. So either every month or maybe every other week, they'll put money into an investment, and then all of those different payments they put in will all add up, but all of them will also earn interest.
Okay, so annuities is the regular payments, okay? Because we don't like the video just said, you don't just put up one amount and wait for it to grow. Usually what you do is, when as an adult, you put every paycheck, you may put money into something, right? So every paycheck you put money into an account that's growing. So that regular payment is your annuity, okay? So let us continue.
These types of investments are called annuities. So in this course, we're going to be examining something called ordinary simple annuities, where we make payments at the end of each compounding period. If we compound 12 times a year, then we're going to be making 12 payments per year. Here's a question we're going to investigate first. Colin is awarded $500 per year as long as he maintains a certain average mark for each of his 4 years of high school. He plans to deposit this award at the end of each school year into an account that pays 4% per year compounded annually.
Okay, so there you go. So he's gonna get $500 a year and he's gonna put it into an account, and that account's gonna give him 4% annually, compound annually. So this first year, he's gonna put in well, let's go through the examples. I don't wanna just say it like that. Let's go, let him explain.
So here are the questions we want to answer. Assuming that Colin maintains the necessary average, how many times will he receive this $500? And will each of these 500 deposits earn the same interest in dollars? So we're going to see if we can explain the answers to those. After that, we're going to try to determine a method to calculate how much will be in Colin's account when he graduates. Just remember that he will receive another $500 at the end of each year. Well, let's start with question 1a. So it says, assuming that he maintains the average, how many times will he receive $500? Well, if he's rewarded $500 at the end of every year for 4 years of high school, this one seems pretty obvious.
Yeah, so he's gonna get 4 times $500, okay? And then will each of the deposits earn the same? No, they won't. Right? Because let it explain.
That he earns after grade 9 will be sitting in the bank all the way through grade 10, all the way through grade 11, and all the way through grade 12, earning interest that whole.
So that is the answer. So will each of these deposits earn the same amount? No, because if I deposit after grade 9 $500, right? So that one there is going to be in the account for another 3 years, right? So that first $500 is going to get more interest on it than the last $500 I put in, because the last $500 is only going to be there for a year. The first $500 is going to be there for 3 years, so it's going to get more interest on it. Okay, so he's going to explain that
whole time. Whereas the $500 that he earns at the end of grade 12, well, that will just go into the bank, but it won't earn any interest because that's the end of the term of the account. So will each of these 500 deposits earn the same interest? The answer is no. Each $500 payment will actually earn a different amount of interest.
Okay, so now determine the method for calculating how much will Colin's account when he graduates. Remember that he's getting $500 per year. So let's go into. So this is just showing you, visually showing what's happening. After grade 9 puts in 500, after grade 10 puts in 500, after grade 11 puts 500, and after grade 12 he puts in 500. So grade 12 will get no interest because the term is over, the time is up. But all these ones will get interest. This one will get the most interest, and then so on. Okay, so let's fast forward. So you can see after grade 11 there's 1 year of interest. After grade 10 there's 2 years and 3 years. Okay, so this would be our future amount if you were to do each one like that. Okay, that's our future amount. So let's stop here. So what are you saying?
Are we multiplying the same amount of each term? And as we go from the first term to the second term and the second term to the third term, notice we keep multiplying a 1.04. So this has to be a geometric series. And here's the formula we use for geometric series. So I guess we can come up with a formula to help us figure out how much interest will be a result, and what the total amount will be at the end of this annuity based on the formula for geometric series. For our example, our A value.
Okay, so not to explain everything in detail, but this is the formula you'd use, okay, in order to calculate the future amount, because it would be 500 and then your number of years, your compounding period, and then your I. Okay, so So this is the future amount. This is the equation right here.
Any annuity where R represents the regular deposits, I represents the rate of interest, and N represents the number of compounding periods, we can find the future value of an annuity as this equation. R times 1 plus I to the exponent N, subtract.
Okay, so that's the formula there. Okay, let's look at this example here and go right into it. Okay, it's drawing you the timeline here. After he deposits $100 every month. He's putting $100 in, okay, every month. So that means it's gonna be 36 months. Okay, so after 36 months, how much money is gonna be in there? And it's compounded. Where does it say here? Compounded monthly. Okay, so here's a diagram. He's putting $100 per month. You know, obviously the first $100 will get the most interest versus the last $100. Okay, so let's fast forward a little bit. So scoring through all the interest. Get into the formula. So here's the formula, right? So the formula is now how many compounding periods for this whole time? It is n times, and then this is where I don't like how this does it. It doesn't do it properly. Okay. This is the number of compounding periods for the entire time, right? So this is equal to, it's compound monthly, so it's 12, and it's for 3 years. Okay, that's how they got 36. Okay, so that is how you get the answer. Okay, you punch that in your calculator and you get your answer. That will be your future amount. Okay.
Time.
Okay, so we're gonna stop here because time has run out. So let's see, can we look at regular present value? Okay, let's look at present value quickly. Well, you know what? You can work on it. I think we don't have time, so you can do that on your own. But it's opposite to the annuity, because basically we're saying what we're saying here in the present value, which I'll just show it here just a little bit. Okay, it looks like I'm frozen. It's not letting me do what I want.
We've now come to the very last lesson in our final unit of our course. And in this lesson, we're going to look at what's called the present value of a simple annuity.
It's not showing on the screen.
In the last lesson, we looked at what ordinary simple annuities were, and what they are just compound interest.
Okay, so when we're talking about present value, is basically the amount of money you need in order to fund a series of regular withdrawals. Okay, so it's a little bit opposite, meaning how much money do I need to have now in order to figure out I can take out $1,000 a month in the future. Okay, so that's what we're trying to do here. So let's get into an example, because the example will better explain. So let's look at this one. Brad and Angeli are about to retire. So this is when you get into retirement. Are talking about investing. They're talking to an advisor about a good money plan. They figure they can live off $1,000 a month for the next 20 years. Okay, so now the key is their regular withdrawals is going to be $1,000. Okay, for the next 20 years. So we can figure out how many years is that, right? For the next 20 years, they're going to take out $1,000 a month. So how many months in 20 years? That's what you're going to figure out. So 12 times 20 will give you how many years that they're expected to live. And then you have to figure out how much money you think you need now in order to be able to take out $1,000 a month for 20 years. Okay. So let's look at an example, right? Quickly, time is running out. So here, they're taking out this much in 1 year, year 2, or these are all the months, up to 240 months, okay? So now you can see there's a pattern here, right? So now we're gonna get into the actual formula, and that's the formula you use. So here's the present value, right? So in order for me to take $1,000 out per month, this is what I need. N is going to be, again, N is your years times compounding period, okay? And this is what you need. What do I need in the future? What do I need now in order for me to take $1,000 out? Okay. So my present value. So here's the answer. So let's go into the answer. He's punching in this calculator, and then he's going to tell you what.
Cents. And there it is. So Brad and Angelina only have to put in away $111,000 right now so that they can afford to pay out $240,000 worth of withdrawals over the next 20 years. That's pretty good savings. That's less than half of the amount of money they're going to be paying out.
Okay, so that is it for the course. You can watch the rest of the video. I'm going to stop sharing my screen, and I'm going to stop recording right now. And that is the end of the course.